Good morning to everybody. On behalf of INEGI, the National Institute of Statistics and Geography, and on behalf of the Metropolitan Autonomous University, I would like to welcome you to this keynote address, which will be given by Dr. Manuel Alejandro Cardenete. Before introducing him, I would like to tell you a little bit about the topic that he will be addressing. My name is Pablo Ruiz Nápoles. I am a professor of the School of Economy at the UNAM. And just like Dr. Manuel Alejandro Cardenete, I am a member of the International Input-Output Association. This association was founded by Professor Leontiev, is in charge of grouping us, and it gives us guidelines. I've been a member of this association since 2002, and we have been disseminating the work of Leontiev around the world. That is our mission as a group. I guess we could even call it a sect that has been criticized, that has been vilified, especially by the Chicago boys, but we're still here. We have survived those attacks. And so, like any other sect, we have our initiation, which, according to Jeffrey Hewins, a colleague who at some point was a bishop of our order, said that our initiation was inverting a 3x3 matrix, which I'm sure some of you know how hard it is, but doing it underwater, which is what really implies some additional skills. And whoever can't do that can simply not be admitted. But we are very generous, and we're always looking to admit new members. That is more or less the work that we do. Last year, we had an international congress that was held in the National Autonomous University of Mexico, which also received the support and was sponsored by INEGI. So we feel very grateful towards INEGI, which is why I'm here today, accepting their invitation, as well as Dr. Manuel Alejandro Cardenete. There is a problem which many of you might not be familiar with, which is that Manuel Alejandro is here on behalf of our current Pope, I guess we could say, our current representative president of the association, who is the Dutch Holland Ditzenbacher, who unfortunately had a medical condition, and he is currently recovering from a thrombosis. Until a few days ago, his situation was very delicate, but fortunately the news that I received just yesterday show us that he is currently making a recovery, and we hope he does indeed. He's one of the most important personalities in input-output analysis. He is also beloved around the world, as well as being a first-class scientist. He has made a lot of advances, progress on input-output analysis, and we feel very sorry that he couldn't be with us today. But we do feel very happy to have Alejandro here with us, also because he's a Spanish speaker, which is something that most people who are born in Spain do, which of course makes it easier for us to communicate with most of you here. So, Manuel Alejandro is not less renowned than Eric Lissenbacher, but he is much younger. He is currently the Deputy Director of Postgraduate Studies. He is Professor of Economics at the Loyola Leadership School at the Loyola University in Andalucía. He has a PhD on economics from the University of Huelva, and he has taken a diploma course on high management in the University of San Telmo. He is from Sevilla, which you can see on his face. He looks like a bullfighter, indeed. And he has also been working with the Jesuits at the Loyola University. They are Jesuits, which, is one of his shortcomings, but I'm sure we can forgive him for that. He's also a professor of economics at the School of Economy of Sevilla. He is president of the management strategy of the Management Association in Andalucía. He is also an academic of the Andalucía Academic Association, as well as the Input-Output International Association. He outvoted me, actually, at an internal election that we had. So, of course, I must recognize that he is a lot more popular than I am. He is also head of research in Climamotive, which is a multi-sectoral model for climate change. He's also an associate researcher of UREAL, the European Union Regional Economics Applications Laboratory in Badajoz, in Spain, of IMDEX, the research group on computer sciences. And he also works on studying the environment and climate change at the University of Sevilla in Spain. He has occupied several positions at the University Pablo de la Vide, also at the Loyola University. He was head of the Department of Economics. He has worked at the Rio Laboratory from the University of Illinois at Urbana in 2002, and the Autonomous University of Barcelona in 1998. He has been professor of the Pablo Olavide University. And so, as you can see, he has a very long resume. Dr. Manuel Alejandro Cardenete Flores. So I will leave it at that. I don't think he needs any further introduction. And besides all of these things, he's also a very dear friend of mine. So without further ado, I will leave you with Dr. Alejandro Cardenete. Of course, it is obvious that he's my friend, based on this very generous introduction that he gave of me. I don't know if anybody can help me with the slides. As Pablo already said, and as you can see it in the agenda, I'm not Rosa Duarte, clearly. She's a colleague from the University of Zaragoza who couldn't be here. And, well, then Eric was scheduled to be here. And, of course, he had a heart attack a month ago. He was at the stadium watching a soccer game from Ajax. That happens to him for not being a fan of Sevilla, as I am, because we've been winning a lot lately. So I'm sorry, that's a shame for Eric. But fortunately, he's making a recovery. And so I was called to come substitute him. I am a member of the Council of the Input-Output Association, and since our president couldn't be here, I was very honored to be here. I was scheduled to be at the Colegio de Mexico next week, so I was invited to come here. So I know I wasn't the first option. I wasn't the main course of this meal, but I'm dessert, let's say, and everybody likes dessert. So the keynote address is about environment and general equilibrium models. So a couple of years ago, when there was a Congress celebrated in the United States, our head of research presented a lecture where he was talking about where input-output was being published around the world. And Professor Nápoles said that one of the reasons why input-output has become so popular once again is how applicable it is to environmental problems. In his work, BART was published at the Association's journal, the Journal of Economic Structure. Those are journals devoted to input-output analysis, but about 80% of the journals that published input-output were precisely of environmental sciences. Townsend Reuter reviewed peer-reviewed journals, industrial ecology, environmental management, amongst others. So what do I mean? Well, that environmental issues work very well with multi-sectoral analysis. Something that falls outside the economic model, as could be CO2 emissions, or as could be power consumption, or as could be water consumption, really work very well technologically with an input-output model, because when technologically it is the connection between the production of X sector and the level of emissions is known, and that can be known by an engineer, then you can almost immediately look at the impact. When it comes to climate change and environmental issues, they are currently in the agenda of politics worldwide, the UN and in every country. That has led to the boom of these kinds of models. So I don't feel very clear as to what to say in this conference, but I want to share something maybe a little bit different about environmental models. Different in the sense that this is not a traditional way of using a general equilibrium model. I have written articles about technology that combines the productive sector and CO2 or NOx or SO2 or water or energy, power, and it is correlated with the model to see what happens in the sector. You can look at what happens if you lower the level of emissions or if you introduce a technological change in X sector to see if consumption is increased or decreased. So it's always about asking a specific question to the model. What will happen in the economy if there is a drop in CO2 emissions? And that's very good. The problem is that in economics, everything in a model is interconnected. What you do in emissions will have an impact on many other things. So policymakers are interested in decreasing level of emissions, but they're interested in many other things. And that's why we started analyzing multi-criteria in general equilibrium models. A problem that scientists face, not economists, but scientists face, is that we are all specialists of our very specific branches, and we don't really interconnect very well. But interdisciplinary work is becoming more popular. So I will be talking about methodology of quantitative analysis, not economy itself or economics theory, but rather how it combines with general equilibrium models, which can give us very interesting results, as you will be able to see. It helps to establish a synergy between different fields of knowledge. So let me tell you a little bit about what we have done. Traditionally, in one of our models, we maximized the function. Yesterday, there was a seminar on the production or GDP subject to restrictions, which is the whole model. When we work with multi-criteria, there's not a single problem, but several problems that we want to find solutions for. So it could be a growth versus inflation, well-being versus public deficit, and so on. In the 70s, this types of modeling became very popular, multi-criteria, and then it was abandoned little by little. The idea was very simple, that there was an exogenous variable and two endogenous variables, which were our goals. So we used the model, we optimized, and we got the optimum policies to be applied in a specific context. The problem of Lucas's criticism is not existent anymore. We can eliminate it either because of household behaviors or because of environmental policies. A model might not be suitable for different economic policies, and that's why we presented a new approach, a structural model, as could be a computable general equilibrium model. This is one of the first works that we did in 2003, 2005, where we had several instruments of economic policies, public expenditure, direct and indirect expenditure, emission charge, a tax on emissions, with several variables of economic policies, growth, public deficit, employment, as well as environmental variables, CO2, NOx, or SO2. We all know that there's a very important variable in the input-output table, which goes over here, and the several components of the aggregate demand. As you know, this is the input-output table, and we close it by using a social accounting matrix. Any CGE model must respond to various components, and I will briefly explain. I will try to skip the equations, but we have a standard of general equilibrium through which we do an approximate. On the one hand, we have producers who work with domestic productions combined with the rest of the world, and a combination of labor and capital. We have countable technology because I have a personal perspective. I think that the less noise we bring into the model regarding technology, the better off we'll be. I have worked with models of the European Union with production functions that a single production function were several pages, and we got very long and complex equations where you couldn't really see where the estimates came from or the elasticities. I have found manuals of programs of the Commission where sectors 1 to 50, the elasticity is 0.2, and then from 0 to 50 it's 0.3. And the first day I asked why, and they said, well, if we don't do it like that, the model doesn't work. And that's the discussion. What I was asking Professor Bayar yesterday, academics and those who do consultancy work for public policies have to reach an agreement. But I always try to calibrate through the SAM in order to have the most similar model that we can to the database, which is an input-output table with an NTF technology. Here we have consumption. A representative consumer maximizes saving. Their net income, or rather their expenses, is on that saving, and the net income comes from the work, capital, and transfers, except direct taxes, where we cannot consider Social Security, which is paid by every worker. The public deficit is the relationship between all the tax incomes and transfers to private sector. Well, with these types of models, I always work with positive disaggregation as much as the database allows me to input, and that's one of the problems. Now I'm talking about the restrictions of databases, often to have a vector. For instance, in Spain with the VAT, the change of SEG 1995, we don't get disaggregated VAT. They say they're going to pay it, and then they tell you no. In Spain, I want to tell people here in INEGI, don't do that. Give people your data. They're not going to do anything weird with them. They just want to create models. And so we get direct taxes, income tax on the one hand, and Social Security. And as well, we have indirect taxes like total production tariffs, Social Security, and environmental taxes. We introduced an equation in order to model the labor market. It's a very old model that was created by someone who had to be here yesterday, but he had a personal problem. But he designed this equation where the real salary, real wage, is equal to the difference between an unemployment rate and a benchmark unemployment rate, and that can allow you to see the unemployment variable. We usually use the wage, which is the standard, and then we maximize benefits for the company. For the rest of the world, foreign sector, we have imports minus net transfers and minus exports, and we have the closure rule, where investment equals savings minus balance of public sector and balance of foreign sector. I'm sorry that I'm speaking so quickly. I'm sorry about the translation, but that's the way we speak back where I come from. Well, in any case, you can see the slides in the presentation afterwards, because it will be available for you. But in the end, we do the calibration of the first benchmark, and I do my simulation. And this is what's interesting. This is an article that was published in Socioeconomic Applied Sciences in 2009, where we did a first multi-objective approach with a model mixing general equilibrium approach with multi-criteria approach. We can use technologies such as goals and compromise or multi-objective, and we picked multi-objective, which made it very easy. There are two different goals, and there will always be an ideal point, which I will try to reach by combining previous factors. This point could be almost impossible to reach, or it could be feasible. In this paper, the first step was growth and inflation. The problem was that for that, we had to see what were the policy variables, public expenditure, and taxes. They established a limit for the model. The variability of the model couldn't be less than 20% of the original value. And from there, we started to see how it could be. There's growth, there's no inflation. So using a payoff matrix and maximizing the general equilibrium model, the maximum economic growth was this scenario with 3.62, the growth of the Spanish GDP, with an inflation of 6.59, which is not tolerable. But if I wanted to minimize inflation, minus 6.76, the growth would be as low as minus 9.69. So the idea was to be able to give a cap for each of the scenarios, and from that, create several equilibrium points between the worst scenario for inflation and the best scenario for inflation, which would be 0.5. We divided the target in 10 points, and we tried to maximize growth. What did we get with that? Well, we got a curve where I have several points plotted on the graph representing those equilibriums, and we found that the observed point of the real economy in Spain in 1995 was this one. So it was possible to improve growth, or to guarantee that growth would be sustained with a fall in inflation. So any of those points would have been optimal. So with that scenario, there were policies that were not feasible or that were inefficient, but we looked at all the changes that could be made to the fiscal policy, both in terms of expenditure per sector and taxes, in order to find a better point than the ideal point. So to find a sort of menu list that government could choose from. So we saw that there was potential, especially for environmental issues, and that led to second analysis work that was published in environmental science, and we tried to analyze environmental problems because economic policies, experts in economic policies, usually what they have inside their head is, okay, environment is important, we have to lower emissions, but that cannot lead to a slowdown in the economy or to a growth in inflation. Everything has to work. So we use goal programming, and we establish the different elements of economic policies that could be used for our model. So we used 4 economic criteria: growth, inflation, unemployment, and public deficit. Basically, the 5 economic problems. The only thing that's missing is foreign deficit to include the 5 economic criteria. And we introduced 3 environmental criteria: CO2 emissions, NOx, and SO2. This is the payoff matrix, which is, of course, much larger than the first one I show you. The interpretation is simple. In the main diagonal line, which you can see in bold, shows us the maximum level of the optimized variable, regardless of what happens with the other variables. That is to say, if what I want to maximize is only growth, and I maximize growth, as we talked about yesterday, in something that we do in general equilibrium models, there would be a growth in economy 2.98. Yes, but inflation goes up to 3.87, unemployment goes to 22.53, and emissions also grow. If we look at any other variable, for instance, if I want to control inflation, the best scenario is 2.28, but of course growth is less, unemployment is higher, but it is positive in terms of levels of emissions. So with this payoff matrix, we tried to establish a series of targets in order to maximize all of the economic policy variables at the same time. I skipped some of the previous tables to go a little bit faster, but what I want to do at the end of the day is to minimize the maximization of all of those variables. I can try to establish certain solutions of objectives where I got reasonable data, reasonable figures here, where I have reasonable figures, and then I force the model to behave reasonably. 2.7 for growth, 3 for inflation, 22.7 for unemployment, 2.9 for deficit, which is less than 3, what the European Union shows, and -1, -2, and -1 for emissions. So maximizing everything, we found that it was possible to reach this balanced solution. That is, that the Spanish economy, giving freedom for the fiscal policy to change for both income or revenue and expenditure, technically with this laboratory, which is a general equilibrium model, would lead to an economic growth of 2.33, inflation of 3.7, unemployment of 23.40, a public deficit of less than -3, and a reduction of emissions in 0.9, 1.3, and 0.9. It was wonderful. So doing this simulation with my colleagues Romero and Andrea, we thought we were playing God, because we were playing around with the models. It takes a long time usually to find that, and it took us a very little time to look at the objective by using a multi-criteria. It takes maybe less than a minute to get the objective because it's working with millions of equations at the same time. But it was possible to find an optimum result where in the paper itself that you can see that was published saw what were the public policies that needed to be changed and how. As a conclusion, I'd like to share another project that's so similar in the Journal of Economic Letters, where we tried to also work with the Spanish economy, with environmental policies, and we introduced more elements. All of these of fiscal policy and all of these of policy objectives, both economic policy and environmental objectives. In this case, just imagine that we're doing a payoff between emissions, CO2 emissions. The best growth would be 4.94, and emissions would grow 0.59, which is not good. If I want to make sure that emissions fall in 2, then my GDP would fall to 3.42, which is not good either. Doing something similar that I did in the previous paper, we got a possibility curve, and we saw that Spain was below. So that means that technically it is possible to decrease the level of emissions and maintain growth, or to maintain emissions and manage more growth. So there was some leeway for public policy. Similarly to we could also analyze 2 and 2 graphically. We cannot represent 3 by 3 or 4 by 4 in the 4th dimension. That's a whole other story that we're not going to introduce here. But by using 2 criteria, we can look at each one of the problems. So relate an environmental tax to emission levels. We also have a new payoff matrix with the maximized goals, again with the main diagonal line in bold, and the results of the other variables. And these are some of the relations, in this case of unemployment versus emissions, fiscal depression and public deficit versus emissions. So this problem had an advantage over the previous simulation, which is that once you have a first estimate of what you can do with real data, you can have a new perspective of what could be your first target to try to find the balance. And using this equation, you can tell the economic policy maker what the importance of each one of the economic criteria will be. In the case of these 5, we have all of the elements of economic policy, and I can assign a different importance to them. So if the most important aspect is GDP growth, I can give it a value of 1. And if unemployment is a little bit less important because unemployment seems to be stable, I can give it a 0.1. And emissions is given also a 1. So I can do a way up in order to see, according to what my main concern is, how to give more weight to one of the variables over another. It doesn't matter if it's employment or public deficit. After doing this, we decided to carry out an experiment, which was talking to politicians, do a sort of real sample in order to set up this part of the model, the value of the omegas, in order to make that our starting point and see what the optimum level would be for Spain. We couldn't do it, but that was part of the goal. So in this case, because we couldn't do that, we gave the same value to all of the omegas. So our economic politicians give equal value to all of the economic criteria. They're worried about everything, unemployment, public deficit. They have the same level of concern, let's say. And we were able, again, through this kind of model, to screen the level of importance assigned to each one of those problems. But we found that there could be an increase in growth of 4.4, a reduction of emissions of 0.9, public deficit of 14 million euros, unemployment of 13.83, and a fiscal pressure of 32.69%. If someone would like to continue with this is just advertising. You can buy the book. I don't have copyright, so I'm not going to make a penny out of it, but you can look at it. It's called Designing Public Policies by Professor Andre and Mr. Romero and myself, where you can see how this kind of model is done. Now I will give the floor back to Pablo for the Q&A, but I'd like to invite you next year in September, when in Mérida, we will have the Input-Output Hispanic American Associations meeting from September 18th to the 20th. And 17th, we'll have the whole day devoted to input-output. So just want to take advantage of this time to do some advertising. Thank you very much.
I would like to thank, on behalf of INEGI, I would like to thank Dr. Manuel Alejandro Cardenete for this presentation of his work, which does a very nice combination of general computable equilibrium. And he's also referred to other elements using the social matrix, the social accounting matrix. So if you have any questions, this is the time for you to ask them. Thank you, Alejandro. Your presentation was very interesting. The exercises were very interesting. Could you please elaborate on what you said? Because I understand that you use a static model, but you're speaking about growth. And that's a dynamic process, and inflation is also a monetary component to consider. I guess you were speaking about cost inflation only here. And the last question, because I have 3 questions, is in terms of the modeling of public expenditure for general equilibrium. It's always complicated in my perspective, considering how do you account for that expenditure? Many people, what they do is they do a lump sum transfers to consumers directly, but you are breaking down public expenditure. I don't know whether you had to divide this into different sectors. How did this disaggregation came about? Horacio, I understood two questions: inflation and public expenditure. What was the third question? Growth and inflation. All right. Every time you send a paper like this on general equilibrium, it's static. This is the typical comment you'll receive. How dare you speak of growth or inflation if it's a static model? And everybody loves dynamic models. I love them too. But they're not less or more elegant than a static one. They are not better or worse than a static one. When we speak of growth in static model, we are speaking about the tendency, the trend of variation of total output, and this can also be affected by the shock of a GDP. That's growth. And when you are working with the static general equilibrium parameters, you have the SAM standard. This technological model is fed from SAM. You get the shock, and then you get a new benchmark, a new picture, and this is a change in a way. So by looking at the output variables, you can estimate a new PB. In the short run, that's complicated. And there are variations, and this could be called growth, with all of the problems of that term entails growth, but inflation is even a worse one, because if you are pivoting everything on a single number, then you need a figure for pivoting the model. It's even more difficult from the theoretical perspective when you refer to inflation, but it's true that deep down within, when this is representing a wage, everything is indexed based on terms of wage. If you have static fixed wages and there is a relative change in prices, then you have a relative change of your basket of products in such a way that the database can help you estimate a new basket in relative terms. This inflation, is it inflation technically? It seems to be, it's not really. But those two terms, growth and inflation, they are terms that in a static model have to be regarded with utmost care. But this is also reflected by the model. If it's dynamic, nobody will complain. When in reality, there's nothing but an equation like the Ramsey model, something that provides a different perspective to the model. Now, in the case of Spain, public expenditure, we don't have a problem with that because at the national regional level, public expenditure is already broken down by sectors. Therefore, we don't need to concern ourselves with that disaggregation. I've never found, working for the European Union, any such a problem. Public expenditure is split by productive sectors. You have an economic agent, and you have a certain amount spent in manufacturing, agriculture, not a lot. And last accounts, the service sectors are the largest usually, and that's where the greatest public expenditure increases are, and that's not problematic. If we had a problem having public expenditure aggregated, and I guess that's what you are implying, then you need a hypothesis to split and be able to disaggregate by sector. Thank you. George? How would you maximize two simultaneous variables? Thanks to the equation, because what you maximize is the equation. For instance, in the final case, you don't, well, the last example of the graphing, where there were several omegas, each one of them was related to economic or environmental policy objective. They were maximizing a function that could correlate all of the elements in the equation at the end. Then, in the mega model, to speak technically, you program RAMs to use one variable, and since this is already correlated to the rest of the elements, it is maximizing each one of the elements simultaneously. So, yeah, it's quite technical. And it's only referring to one variable at a time. The summary of multi-criteria is a mathematical technique to be able to introduce at once several problems, several optimizations within a single optimization. That is the summary of the summary of the summary. Could you please start by saying your name? Arturo Pérez Mendoza. Let me understand some of the results, because I'm trying to understand how this optimization process takes place. For instance, a specific result that was presented is that there's a possibility of having the same level of pollution but greater growth. What are the variables that are adjusted within the models to allow the economy to grow further without having to pollute more? What is in the model that would allow for that? And another one that is also related to this is, how is it possible that the model can grow, or rather, can show a 3-4% growth if static models, generally speaking, because of the having a fixed labor and capital amount, then there will be an important growth restriction for the economy. So in this case, why is there growth, especially at those rates? Because static models, usually speaking, don't grow a lot, unless you increase labor or capital. I start with the last one. It is not a 3% over the original. It is a rate that is compared to the rate of that year. So if it was a 3% growth, it was 3.4. The growth was of, as I mentioned, I was very quick, perhaps was not clear enough. It's not that it's growing at 3.4, but rather if that year, in the year was of 3, it became 3.4. The static model, as you're mentioning, since those things are limited, it wouldn't happen. Now, about the rest, let me see if I understand the question and see if my answer does answer. In the case of the multiple criteria, an intermediate step is necessary with the payoff matrix. You take each one of the variables one by one, following the traditional general equilibrium method, where you get growth. You maximize the payback, and you let the other ones free. The second scenario, the second simulation, is maximizing the employment or minimizing it, and the rest is the same, and you get different outputs. You create a matrix, and once a matrix has been created, the elements help me find information so that the model, by using the multi-criteria equation, according to how you do the programming, you maximize all of the variables by giving freedom to all of the fiscal policy variables, respecting, as I mentioned, or somebody mentioned, not having fiscal policies that go beyond the 20% growth or decrease to prevent laughable matters. It could go down 20% tops, up or down. We restricted the variability of the model to a reasonable limit and threshold, and that is how you get output with growth or by a reduction of emissions with a small growth, with no problem. But usually, if you look at the paper and see the sector disaggregation, you might realize that the great polluters are taxed a lot, others aren't. And some things I have to be careful as a politician. In my experience, when you give information to politicians, they take it as if the law, yeah, let's increase the tax by 18%. And you got to say, no, the model is only telling you that if you make this tax growth as much, and this is not growing, perhaps you might get this. As a matter of fact, if you look at the paper, it's like a recipe list of the added value tax and this or that. But as I said, you have to be very cautious with the recommendations you give. The last question, because we've ran out of time. Yes, this question is start by saying your name, Federico González from INEGI. This question has to do with what Arturo had mentioned of the relationship of GDP growth with polluting emissions. I was saying in the model that the relationship that exists is constant, in spite of the fact that you maximize. However, I'm trying to figure out how to use those models based on the tendencies, trends with real statistics and real happenings, because in the accounting that we do, we get samples of a decoupling that exists between GDP and polluting emissions. The gap is becoming bigger and bigger. And the same thing with hydrocarbons. In the model, I do not see that. I also have information when public expenditure was discussed, in which if you look at the trend of the percentage of public expenditure is devoted to the environment from a historical perspective, it's constant. It remains constant regardless of the growth or the drop of GDP. The proportion is of around 1% of what is allocated to public expenditure. So how can you include all of that in the model? How can you adapt it, considering that there's evidence that points to the fact that by 2017 the expenditure, or in the case of the environment, it will drop a lot. So how can this be reflected following this scheme? Okay. There shouldn't be a problem as long as you have the right engineering data of how the sector and the emissions are correlated. But this is by Leontiev. This is not my idea. During a dinner in Spain, Basil Leontiev visited the president of the tribunal, Sontela, one of the people who brought this model to Spain. There was a dinner, and during the dinner, the professors were talking about input-output, and Leontiev would remain silent. And all of a sudden, Leontiev wouldn't talk to anyone, and somebody asked him, "Professor, do you believe then that all of the tables, do they make sense?" Because everybody was arguing about the problems and that. And Leontiev would say, very slowly, he was very old, he said, "If you wanted to understand this, you need to go and ask the guy who has a pencil at the factory behind the ear. They are the ones who know how the economy works. These people at the factories, those are the engineers who know precisely how to combine the L and the K to produce, you name it." The more information you have, the better your approach to reality. In the idea into switching into dynamic to feed technological relationship of the productive sectors and the emission levels is reasonable. If the more information you have, the better the model would be. So I don't see where the objection would be. As I said in the beginning of my presentation, speaking about the environment is an ex-post introduction. They have the environmental satellite accounts, and then you embed it. That's how you insert it. We thank all of the attendees, Dr. Cardenete. Thank you very much for your presentation. And if you want to talk to him, you can ask them on the outside, because we need to start with the next panel. We thank the doctor for his presentation.